Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to continue on with Eloquent JavaScript. Talking about Chapter 2 today, all about program structure. We're going to be getting into loops today, statements, just basically building on what we talked about last time. What did we talk about last time? We talked about values in JavaScript. We talked about like numbers, strings, booleans. We talked about the operators. We talked about type conversion, short circuiting the operators. If you guys remember that, if you don't, please watch the chapter 1 if you want to have that sort of introduction, because we're going to be using some of that stuff today as well, namely the values stuff. So program structure, let's jump right into it, guys. Program structure. So here we go. Expressions and statements. So what is an expression? Well, Mergen, hopefully I'm pronouncing that right, Mergen Haverbeek defines an expression as a fragment of code that produces an expression. Inside a parentheses could be an expression. A binary operator can be applied to two expressions. So these were kind of like main bullet points that I took down from this section of the chapter. So mainly, an expression is something that evaluates, right? It's a fragment of code. It's something like inside of a parentheses. So if you have like an if statement, right? If statement, inside of this parentheses, you have an expression. If 6 is greater than 5, right? This is an expression. This would be an expression. Anything that evaluates. A binary operator can be applied to two expressions. So even like it's saying that even these can be an expression. So let sum equal 6 plus 5, right? This is an expression. This is an expression. It can be applied to two expressions. Mergen was saying even like a unary operator could be done to an expression. So like even in a unary operator case, like the not symbol. If you guys remember this, so let is it true equal to, right? Even in this case, this is an expression too, right? The not operator. So that's what an expression is. What's a statement? Well, a statement is basically a program. It's a list. A program is a list of statements, and a statement is a combination of expressions. So this is kind of how it all formulates out. So this would be the statement, and then this would be the expression. And then this is the binding name, or the variable name, right? This is the expression, this is the statement. This whole thing is the program, because this is a collection of statements. And then what do we have here? Expressions can be content to produce a value which can be used by the enclosing code. So produces a value, and then this entire expression here produces a value, right, that we are assigning to this binding name called sum. Statements stand on their own, and they amount to something only if it affects the world. So expressions are used by statements. Statements affect the whole world or your whole program. And it's kind of like these statements kind of just stand on their own, right? 6 and 5, they stand on their own. But once you add them up and assign them to a binding name, a variable name, that's when you have a statement, because now this could potentially affect your program. Like if you console.log it, or you can add it to another variable that contains a different sum, right? So that's kind of how the structure flows of a program. Hopefully I'm making sense here on this. Let me clear my console. Next slide. Bindings. Oh gosh, I got a little ahead of myself. Bindings are how a program keeps internal states. So when I was saying assignment, I like to use that word because this equal sign does not mean, hey, we're checking if it equals. This is an assignment operator. If you guys remember from chapter 1, if we wanted to check if something was equal, we would say double equals, and then that we could take one step further. We could use triple equals to check precise values without type coercion. So in some cases, JavaScript will do type conversions with the expressions on both sides of the operator. It will, if they are different types, JavaScript will attempt to make them the same type and then compare them. That's what happens when there's a double equals. So just remember, double equals, type coercion. Triple equals, we're checking just as they are. Precisely are they equal as they are. So as an aside, okay, back to bindings. Also called a variable. That's how I know it coming from Java world. Binding I always thought was like a crazy complex theory, like data binding in JavaScript. I was like, whoa, I can't wrap my head around this. Well, no, that's just assigning values to a variable. And all this time, I always thought this was something like really complicated, but it's not. You're assigning, like in this example here over here on my PowerPoint, you're assigning the value 5 to the variable named caught. Let is the keyword that defines the binding. Caught is the name of the binding, and then 5 is the value you're giving to the binding. And then after the binding is defined, you assign the value to it. Now that can be used as an expression. So let sum2 equal 10 plus 10. All right. Now, what do we get here? And as you can see, 31. So you can now use these bindings as expressions themselves here, right? And remember, what's an expression? Just a fragment of code that stands on its own. That evaluates to a value, right? This evaluates to 11. This evaluates to 20. Now, you can add these two up because the values there's values assigned to these variables. Number values specifically, right? That's how you are able to print this off, and it prints off the sum of sum and sum2. Right? It's keeping that internal state in these variables. There's also, Mergen touches on var and const as well as let are all used to define bindings. I mainly use let, and then I also use const. Var I feel like is not as common, especially in this current version of JavaScript, the ES6 version or the ECSMA script 6 version. I feel like var was more common in previous versions, and I think are going to get to the differences between all of these later on in the book. But I know that let is something that's very local. I like to use let inside of loops. Const is for constants, so it should be for variables, for values assigned to variables that you do not want to change. Let is more used for times where you know that the value of a variable is going to change. And then var has its own reason for being used as well, but we won't get into that right now. So the binding names, like I have here, sum, sum2, those are valid names. You can have numbers for names, but they can't start with a number. So as you can see the rules over here on the PowerPoint, binding names can't start with a digit, but can contain digits. So if I try to do this, oh, and look at there, it's saying there's an error because I have two variables called the same thing. You also can't do that. But here, if I try to name that toSum, it's going to also throw an error, as you can see there. Can it start with an underscore? I think that's valid. Sum2 is not defined. Oh, yeah, because this down here. So if I do this, now that should work, I believe. There we go. Welcome, and then 31. So it just can't start with a digit. But it can contain digits. It can also include the $ and underscore, but no other punctuation. So no commas, no exclamation points, no question marks. And also, you can't use special keywords for binding names. So what are some special keywords? Well, we've been using some. Let, for, catch, break, while, do. I'm pretty sure you probably can't use console. This might even throw an error. Yeah, you can't use console. That's a special keyword as well. So just keep that in mind when you're naming your bindings, and also try to have them be relevant to the particular task at hand for your code. So, you wouldn't name this, let difference equal 6 plus 5. I mean, you can, but wouldn't it make sense to say sum because you're adding these numbers, right? So just kind of be mindful of your binding names and have them be pertinent to what you're trying to achieve in your program. Environment, what do we have here? Collection of bindings and their values that exist at a given time. Okay, right. So your whole environment is kind of like your program. Like program's a list of statements. Well, the environment is the list of bindings and their values. So this would be your environment. I guess this whole thing. Let's continue on to the next slide. Get rid of the errors annoying. Let me get rid of that. Oh, yeah, okay. We did talk about functions a little bit in this chapter. So what's a function? Let me come. Actually, do you guys mind? I'm going to erase this and we'll clear the console. What's a function? A function is a piece of program wrapped in a value. So as you can see right down there in my PowerPoint, prompt and then enter password. This is a function. Binding prompt holds a function that shows a little dialog box asking for input. So prompt is like the binding name. It's holding the function in that name. That function is taking one argument, and it's a string. And the string is going to say enter password. So this is going to pop out. I don't think this does anything. Oh, okay. Maybe it does. Embedded page at CDN. Okay. So see there, it takes the input, which I had as hello. There you go. And it outputs this dialog box, this alert box. And alert does this kind of a similar thing with that argument that I passed into it up there, hello. Let me delete this before it gets crazy. Right, so values can be applied in order to run the wrapped program. These values given to functions are called inputs, or I call them arguments as well. So this is taking one argument, and that's a string. How do we know it's a string again? Because it's in between two double quotes. So you call a function by putting parentheses after an expression that produces a function value. When a function produces a value, it is said to have a return. We've already kind of been using functions, right? So this console.log log is a function, right? It takes in a string or a number, right? So you call the function by calling it the function name or the binding name with parentheses. So let's define a function. Am I getting a little ahead of myself? No. Okay. We're going to talk more about functions in the next chapter, but we'll preview this a little bit. So we want to define a function, and there's different ways you can do this. Let's see. Let first function equal I don't know if this is going to work. And then let's see, first, wonder if this is going to work. Oh, it did work. Okay. So what did we do here? This is just one way to write a function. And again, I might be getting a little bit ahead of myself here, because we're going to talk about functions in the next JavaScript video. But this is one way to write a function. So you, again, binding name here, and then we're assigning a function to it. This function, all it does, it's going to print 6 plus 6. So it's just going to print 12, right? So now to call it, again, we have to call it by putting the parentheses after it. Oh, geez. By putting the parentheses after it. So this is calling it. So essentially this is calling it, and it's going to print 12, as we can see down here. This doesn't really do much. This won't do anything. Now, you have to call it with the parentheses. Now, function x, 6 plus x. You could also do this, I think. Yes, that did work. Okay. So now you're assigning a function that is going to take one input, and now you are going to print 6 plus whatever that input is. So now this first function has to take an argument, right? So it takes in 6. Now, what if you do no argument here? Not a number, because you're not passing in a number. So that makes sense. So now if you're passing in 6, this x turns into a 6, this x turns into a 6 here, and you get 12. Let's continue on forward, because again, we're going to talk about functions next time, and I don't want to keep you guys too long. So what are we talking about next? We are talking about control flow and conditional execution. Oh, the if statements. You guys have seen me use the if statements, and I wasn't even explaining myself. How dare I do that? We're going to comment this out. Bam. And we're going to talk about comments later on in this chapter too. So, when a program contains more than one statement, the statements are executed from top to bottom. Right. So it's very linear, right? Top, bottom. But sometimes the path branches, and this is where we get conditional execution. So sometimes it goes from top, comes over here, then bottom. Sometimes it can go straight down, or sometimes it can branch off. So how does it branch off? Well, you use conditional statements that are basically going to evaluate Boolean expressions to see where the program goes. And you do that, as you have seen me use, if, and then block, right? There's also else if, and then block. And then finally there is an else. So, you crazy. So if, let's start out with this. So inside the parentheses of an if statement has to be something that evaluates to a Boolean. So 5 greater than 3 greater than 3. Unexpected token? What are you talking about? Else. All right, I'm sorry, guys. It's yelling at. It's being very sassy. Let's just focus on the if. So, is 5 greater than 3? It sure is. So now the code in the block executes because this evaluates to true. That's how we enter into this if block, is if this Boolean expression evaluates to true. Now, is 5 greater than 6? It is not. So what's going to happen? Nothing's going to print here. So as you can see, 5 is greater than 3 does not print. Right. So that's an if statement. Ifs can be chained with elses. So you can have this else block that will execute everything in the block. And I don't know. There we go. Okay. There we go. Does that work? Yeah, that works. Come on. Come on, man. So the else block can be chained with ifs. Else runs if the first if the if before it evaluates to false. So if this is not true, then this runs. As you can see there, is 5 greater than 6? It's not. So that's why it prints else here and not the 5 is greater than 3. Now I say the top if, because what if I had another if here, right? 5 greater than 5. Don't get sassy on me, CodePen. Oops. I say, you're going to see what I'm talking about right here. 5 second if. So, is 5 greater than 6? It's not. Is 5 greater than 5? Print second if, but it's not. So now this prints. So now check this out. Both of these are false, right? So the else runs. Now what if we do here is 5 less than 6? Five less than 6. Oh, come on. It didn't evaluate to nothing. There we go. Okay. So is 5 less than 6 true? Right? But then here's the thing. It's the top if. So what am I trying to say here, guys? This if runs and prints, right? But this if is chained to this else. So that's why you see the else also printing here. God, CodePen is being very, very rambunctious today. That's why you see this else printing. So this prints and this else prints because it evaluates this to true, right? But it doesn't skip this if and this else. No, it's going to come down here and it's going to still check this. And if that is false, it's going to print else, as you can see here. Else gets printed. Now, hopefully I didn't confuse you guys. You have an else if. Else ifs can be chained to ifs and can be chained with an else, but else's always come last. Else ifs come after the if, because if you just have a bunch of if statements, it's like they're separated. You're checking each and every single one. So sometimes you want that, but sometimes you don't. Sometimes you just wanted to do a check. Like let's say in this instance, let x be equal to 10, let's say. Is x less than 6? Else if x is greater than 5, what's going to happen? Second if. Actually, let me put this, else if. So now this whole thing is kind of chained together. So it's going to check the if. If that's false, it's going to go to the else if. If that's false, it's going to go to the else, right? Before, if this was an if, it would check the top if. Even if that was true, it would still check the second if. Then if that second if was false, then it would go to the else. This way, it's kind of all chained together, and you can use it to have multiple checks, especially with variables. You can use it to do multiple checks. Else ifs come in handy a lot. I'll say that. Hopefully I didn't confuse you guys there. Let's continue on. While and do while loops. Oh, yes. One of my favorites. Yeah, you know what? Let's just delete all this. So while and do while loops. So looping. Looping allows us to go back to some point in the program where we were before and repeat it with our current program state. So if you wanted to print numbers 1 through 10, how could you do it? Well, you could do it this way, right? And you could change, that to 2, that to 3, that to 4. And you can go all the way to 10, right? And that would accomplish it. Or a much cleaner way would be to do a loop. So there's while loops and there's do while loops. So how would you accomplish this with a while loop? Well, how does a while loop work? Well, a while loop works kind of like an if. So you have this while keyword inside of these parentheses. This is where you would put in something that evaluates to a Boolean. So let's say let counter equal 5. Or we were saying 10, right? Let counter equal 10. Counter, as long as counter is less than, let's try 11, excuse me. We're actually going to go 0 here. And let's actually go 10. We'll say as long as it's, less than or equal to 10. So we have this counter variable, right? We assigned it a number of 0. So this while loop is going to run as long as the counter stays less than or equal to 10. And this is going to check at each iteration of the loop, or like each turn, like your NASCAR. Every time you make a turn, or you're on the Monopoly board, every time you pass go, it's going to do this check for counter. So look at this error I'm getting down here, an infinite loop. Well, 0, counter is always going to be 0, which means it's always going to be less than or equal to 10, which means this loop is always going to run. So you need a way to break out of loops. So how would you break out of a while loop? Well, first off, what were we going to accomplish here? Console.log counter. How do we break out of this loop? Well, counter, you can use a break statement. So you can do that. But again, we want to print everything up to 10. So you could break this, right? You could break out of it, but what good is that going to do you? Because it'll only print print off 0, right? So, and I wonder, why didn't that break statement work? That's very strange. That should break me out of here. I don't want the unsafe changes. Huh. Yeah, very strange. Okay. For some reason, that break didn't work. But that would normally like break you out of the loop, right? But you would have just printed 0. We want to print 1 through 10. So now we have to update the counter. And this is why I put it outside the loop. So scope-wise, and I'm sure we're going to talk about scope later in this book, scope-wise, it starts at 0. And when we do something like this, counter increment, right? Nothing is printing. Why is that happening? I wonder if I just have to refresh. Or if my internet's down. Oh, I probably shouldn't have refreshed. Anyway, now the counter variable is going to update. So this would, counter plus plus would mean counter equals counter plus 1, right? This would be the same thing as writing counter equals counter plus 1. And now this is going to evaluate. What's that going to be? 1. Is 1 less than equal to 10? Yes, it is. So then it enters the loop again. Counter equals counter plus 1. Is 1 plus 1? That's 2. Okay, then it's going to come back up here to counter. Is 2 less than equal to 10? Yes, it is. If I define this counter variable inside the loop, what would happen is that it would keep being reassigned to 0. We don't want that to happen. Gosh, CodePen. Oh, man. We don't want that to happen. So that's why we define it outside. And when we talk about scope, we'll bring this back up again. So that's what a loop is. Oh, there we go. Finally, jeez. So that's what a while loop does. A while loop runs until the Boolean expression is no longer true. Now, there's also a do-while loop. A do-while loop is similar to a while loop, except that the body executes at least once. So the do part here executes at least once. And if, I am so sorry, guys, if CodePen was being cooperative, I could show you a do-while loop. I got to open up a new thing here. All right, that is kind of better. So do this. So do console.log counter plus plus while counter is less than 10. Oops. Let's see what happens. Oh, counter is not. Oh my gosh, I'm in the HTML. What a dummy I am. Here we go. Boom. Let counter equals 0. Let's see what happens. Okay. So the do automatically runs at least one time. At least once. Then the while loop check happens, right? So this is kind of how you write the same code that I did previously. Did I still copy that? No, shoot. I overrid it. But this is kind of how you write a do while loop that corresponds to that while loop that we just wrote a few minutes ago. And what if counter is less than 1. What if we do this? Right? So the do still runs. If counter is less than, how about this? Counter is less than 0. It still prints 0, right? Because the do comes before the while. So this is going to run at least once. Counter equals 0. Printing off counter, that's 0. Counter plus plus. So what's 0 plus 1 is 1. Is 1 less than 0? It is not, so it doesn't print again. This was from the previous iteration, but this 0 printed off as I changed the code to this. So the do always runs once. Well, okay, that's pretty cool. Do and do while loops, but what if we want our code to run like specifically, you know, a certain number of times, which you kind of saw with the while loops. I have that counter there, and we're doing a check every time the counter increments that it stays below a certain number. Well, you can accomplish this also with a for loop. So a for loop, using the keyword for, it's going to contain 3 parts, and you can kind of see that in my PowerPoint. It's going to take an initialization, a Boolean check, and an update. Kind of everything you saw with the while loop. So in the while loop, we did have an initialization. Or let me, for clarity, we did have this initialization, right? In the while loop, we did have this conditional check. In the while loop, we did have this update, and in this case, we're incrementing. Right? And look at that. It prints 0 through 9. If I wanted to do 10, I would have to do this. Boom, there's 10. Right? We did all of this in the while loop. It's just in a for loop, it's a lot nicer. Everything's contained within the parentheses, and you use the semicolons to block off each section. Again, first section, initialization. Second section, the Boolean check. And then the third section is the update, updating the variable that you initialized. So this comes in handy when you know specifically how many times you want something to loop. This comes in handy with arrays and lists. When you know the length of your array, you can use that here because length is a property of an array. Property or method? Property. Property. So you'll want to do something to each index of that array. So you'll loop till you hit the end of the array. This is a great way to do that. So the for loops come in handy with stuff like that. Loop will end once the Boolean check yields a false. So right as counter, again, just like we saw in the while loop, once counter reaches a number that's not less than 11, it's going to break out of the loop. And again, this break statement did not really work. Okay, so now it finally works. So it printed 0, then it just breaks out of it. There's also the continue statement, which basically just continues with the next iteration of the loop. So this comes in handy if you're catching exceptions, and after you handle an exception, you just want to continue with the next iteration of the loop. So the next round around the Monopoly board, you just continue. And as you can see here, even though I added this continue here, it basically just, again, prints off 0 through 10. Same thing as if I didn't have the continue there. The continue just tells the program, hey, continue to the next iteration of the loop. So it prints 0. Okay, just go on to the next iteration, which is where counter is equal to 1. Do the check, print 1, etc., etc. Let's go to the next slide. Binding updates. So this is, exactly what I was showing you guys before. Counter equals counter plus 1, which can also be written counter plus plus, only when you want to add 1. So that's only incrementing 1. And you can also use it to decrement. So let's console dot. Let's do let x equal to 5. And then let's console.log x minus minus. So this is a decrement. What's it going to print off? Oh, jeez. What should that print off? 4, right? And it didn't. X equals 5. But I'm just curious, what does x plus plus yield? That also... Huh. That's really interesting. X equals 5. 5 plus plus. 5 equals 5 plus 1. Oh. No. I feel like that should print... Definitely print 6. Yeah, very... Very interesting there. But binding updates, so there are some special like shortcut ways that you can write the updates. So again, the update here is the increment. You know, you're just incrementing by 1, but you can also write this counter plus plus as counter equals counter plus 1. It should accomplish the same thing. That's what it looks like it did. It's still printed. Okay, never mind. I guess I learned something new. Counter plus plus. But the same, you can also write this by counter equals counter plus 1. So it reassigns the counter variable name to whatever counter was before plus 1. But you can do this with let x equal... How about this? Let x equal 5, and then let's say x plus equals 5. Let's say console.log x. What should that print? Hopefully 10. Oops, that was bad on my part. So just ways to update the binding and some shortcuts on how to do it. You can do it this way, x plus equals 5, which is the same thing as writing x equals x plus 5. Right, just a little bit of shortcut. You can do this with minuses. You can even do this with times as well. X times equals 5. I'm pretty sure you can do this. And again, CodePen is acting up. I'm so sorry, guys. Division, I believe you can do it with division too. I don't really see that. That's not very common. The plus and the minus are way more common, and that's kind of how you can update your binding. Or if incrementing or decrementing by 1, you can use this shortcut again, counter plus plus or counter minus minus. This comes in handy with, not just how you write your for loops, but also if you're trying to build a string and trying to like concatenate strings together, comes in handy with that as well. Switch cases, all right. So switch cases is kind of another way to do if, else statements. It's kind of very similar. You're basically accomplishing the same thing. So switch the case to match. Everything's contained with this in this block, and then you have these cases, right? So the syntax is just a little bit different. And the spacing can be a little bit different as well. So this is basically saying, here, this is the case we want to match. We want to see which case matches this string hello. Fair enough? So, case hi, we're going to hallelujah. And then let's have our default console.log by default. Okay. So you can see here, this is the case we want to match hello. It enters the switch block and it's going to find whichever case, that's another keyword, is going to match hello. Once it finds the match, it enters that case block. And it's going to run the code, whatever's in that block. Now, I really wish this was CodePen was cooperating here. I might have to open up another. Oh my God. Yeah, I might have to open up another CodePen window. That's just great. Fantastic. Yes. Okay, it did what I wanted it to do. So it printed world because hello matches it, right? But it also printed hallelujah, and it also printed by default. Default will always run. So it'll always enter this default block unless you break out of a case earlier. And that's where you see I have a break statement here. I didn't have a break statement here. So even if a case matches, if you don't have this break here, the next cases will run. And the code inside that case will run, and the default will run. So to ensure that doesn't happen, you put a break here. So now, only world printed. Only world printed. Because after world prints, we have this break statement, and it breaks out of this switch block, of this entire switch block. So now what happens if you don't have any cases that match, right? Maybe you just have this. What's going to print? By default, right, because default will always run if no other cases match unless you broke out of one of the cases that matched earlier. So that's a switch case. And you can kind of see here how this can be used as an if-else. Like each case could be like else if hello equals hell, else if hello equals hi, else by default. It's kind of another way to have some checks, right? Except for inside the switch parentheses, that's the case to match. It doesn't evaluate to a Boolean expression. Again, inside the parentheses here, this is what we want to match. And then last couple slides here. Camel case, you guys might have seen me write in camel case. I'm going to delete that just so it doesn't freeze up again. You might have seen me writing in camel case with variable names. This is just like a coding kind of standard. Like instead of naming your binding names for all my equals hello. Oh, I wonder if you can hear my phone in the background. I apologize for that. For all my hello. Okay, so this works, right? All uppercase, they're all letters. Again, it doesn't start with a digit. So this is okay. But why would you write it like this? Now, I have seen in Java writing constants in all caps and using underscores. I have seen that. But for just regular variable names, if you have to use multiple words for your variable name, start the first word as a lowercase, and then every successive word after that, capitalize it. So they call it camel case because it looks like a camel. This is camel case, lowercase, uppercase I, C, C. These are like the humps on a camel, and the head is hanging lower. So how would you write this in camel case? Well, I would do for, and then all my. Excuse me. For all my. And it just kind of looks a little better. It's just kind of like a coding standard, best practice, something to keep in mind. And last slide, comments. Yes. Commenting. A piece of text that is a part of a program but is completely ignored by the computer. How do you comment? Well, for a single line, you use just the double slash. Now I'm running into this error because it's telling me for all my is not defined because I commented it out. Double slash for a single line. But if you have like a big block of text, you can use this slash star and then star slash opposite so that everything in here will be commented out. Blah, 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 blah. And you can kind of tell too in a lot of code editors, like here in CodePen, it changes the color of it. So you can kind of tell it's commented out. Like this first line here with the binding name for all my, look how it changes color. So it kind of alerts you that it's commented out, right? So that's commenting things out. I guess we don't have to talk about best practices here, but I guess it's not really best practice to have comments in the code, I've been told, although I do sometimes leave comments in my code, just notes like for myself or for other people when you make your commits to your repository so people know kind of what you're doing. But I've also been told that your code should speak for itself. That means your binding names, your naming convention of your classes, methods, functions, etc. They should tell the story. The comments shouldn't tell the story for you. So just something to keep in mind for the future. Well, we got through it, guys. Woo! What a doozy. Oh, gosh, more crazy stuff. Thank you guys so much. I'm sorry for CodePen being kind of a pain. I don't know why I was freezing up like that. I might just have to code with you guys on VS Code. But thank you guys so much for sticking around, watching any part of this video. Hopefully you're getting some value out of it. I really, really appreciate it. We're going to continue on next week. We're going to talk about functions, or next week, or the next time. Next video, we'll talk about functions, so we'll dive deeper into that. I know I touched on that a little bit here. And look out for the other videos on the other books that I am doing. And guys, thank you so much. Let me know what you think about the presentation here. Let me know if you have any questions. I'll do my best to answer. Please like and subscribe. And that's it. My name is Chris. This has been Chee-Tash. Take care.